opposite, if this is the angle, what's opposite over hypotenuse? What would you write? Negative 1 over root 2, but we do rationalize it. This would be negative root 2 over 2. Okay, let's go to cosine. Isn't cosine going to be the same? Okay, cosine is adjacent over hypotenuse, or if you're looking at this sheet, it's x over r, same thing. I'm going to skip right to the rationalizing. If I rationalized it, it would be negative root 2 over 2. Okay, how about the tangent of 5 pi fourths? Negative 1 over negative 1, which is 1. Let's go to reciprocals. The reciprocal function of sine is cosecant. So I'm going to go back to, you can use again either reference sheet, or I'm going to flip this around. That would be root 2 over negative 1, or negative root 2. The secant of 5 pi fourths is going to be the same. And how about the cotangent of 5 pi fourths? Fine. Okay. So what if I ask you just to do one trig function, not all of them? I just wanted to show you how you go through with all of them. You got to make sure that if I say don't use your calculator, that you understand it's a 30, 60, 90 or a 45, 45, 90. Okay? So let me give you just one more that I ask you to evaluate and see if you can figure it out. Let's do the sine of (11 pi 6). Okay. Now, this is where when we do learn unit circle, it will become, you're going to know those quite easily, because unit circle is a really good way to memorize the radians. Does anybody remember what sixths are, though? 30. They're 30. And let me just point out to you, isn't 11 pi 6 just 1 pi 6 shy of 12 pi 6? Okay. That means it's 30 degrees shy of a full rotation. So if I was drawing a picture of this, this goes all the way around and ends 30 degrees shy of that. That makes this reference triangle make a 30-degree angle, okay, or pi 6 angle. All right. Now, if you need to cheat and look back at your notes, do you guys remember the triangle we used for that? 30, 60, 90, yep. The shortest piece was 1. The hypotenuse was 2, and the shorter leg was root 3. Okay, which of them would be negative? What's that? Nope. Because this is the long piece, and this is half of that long piece, because it was split in half. If I were to complete it, this would be 2, this would be 2. Okay, so the hypotenuse is 2, this is 1, and this is root 3. Root 3 is smaller than 2. So this is positive. What's 1? Negative. Okay, let's do it. We're going to use our reference piece. So you can use your coordinates if you want, or let's use opposite over hypotenuse. what would be the sine of 11 pi 6 then? Well, what's opposite? This is the angle right here, the one it makes with the x-axis. Which is opposite? -1. What's the hypotenuse? 2. Okay. This is, so reference triangles are good. We're going to use them a little in your homework today, but when we do exact ones, in my opinion, it takes about as much time to draw a whole unit circle, and then you have every single exact one instead of just one. So some teachers will say draw reference triangles for exact measures. You should know how to do that, but when we go to unit circle, which will be when we get back from break, and you have to memorize the unit circle, then you're going to have a whole slew of all of the exact ones instead of just one triangle. So that's my philosophy on that stuff. Alrighty, let's do a little homework.